The evolution of aviation has brought about remarkable changes. From commercial aircraft transporting passengers to hypersonic jets capable of supercruise, these advancements are astonishing. But being able to fly at speeds twice the speed of light is just the beginning. Modern aircraft can remain hidden, carry the world's deadliest weapons, and strike targets with incredible precision from afar. The world of military aviation has seen it all, or has it? What are the latest and most intriguing innovations in airfighter technology? Join us as we explore the incredible capabilities of NASA's Invisible aircraft, as well as some of the most amazing airfighters in the world. Beginning with one airfighter that has made the Russian Air Force one of the most formidable in the world, let's delve into the capabilities of the Sukhoi Su-27 flanker. With a top speed of 1,788 miles per hour, this aircraft shows off the Soviet engineering skills. It is also powered by twin engines and was the first Russian jet to use a fly-by-wire control system, thanks to their experience from the T-4 bomber. This system, along with its low wing loading and strong flight controls, makes the Su-27 very agile, even at low speeds and steep angles. At air shows, it can perform impressive maneuvers like the Cobra, where it briefly flies level at a steep angle. Designed to dominate the skies against new American fighters like the F-15 Eagle, it comes with a 30mm gun and 10 pylons for holding various missiles. Despite being introduced in 1977, its success and popularity have led to many updated versions, some of which are still highly advanced today. The Su-27 looks a lot like the United States' MiG-29, but is much larger. It has semi-delta wings attached at the middle of the fuselage, with tips cut off for missile rails or electronic countermeasure pods. The plane also features a tail with traditional horizontal tailplanes. The Su-27 features a phasotron and 001 MEC radar that can track targets while scanning and has look-down/shoot-down capabilities. It also has an OLS-27 infrared system in the nose with a range of about 80 to 100 kilometers. The Su-27 is armed with a 30mm Gryazev-Shipunov GSH-31 cannon and has up to 10 hardpoints for missiles and other weapons. For air-to-air combat, it typically carries a mix of R-73 and R-27 missiles, including versions with extended range and infrared homing. The General Dynamics F-111. Aardvark, the F-111 is not a fighter, but a tactical bomber capable of flying at 1,902 miles per hour. Before its retirement in 1998, it had 9 hardpoints and 2 weapon bays, capable of delivering a payload of approximately 31,000 pounds. This included bombs, nuclear bombs, air-to-air missiles, or a 2,000-round machine gun, though it was rarely fitted with the gun due to the Aardvark's rolling air. It was the first aircraft in production with a variable sweep wing configuration and was also tested for carrier-based operations, though this was never completed. The F-111 was an all-weather attack aircraft designed to fly low and bypass enemy defenses to hit targets. It had wings that could change shape, an internal weapons bay, and a cockpit with side-by-side seating, all protected by an escape crew capsule. The wings could sweep between 16 and 72.5 degrees and had features like leading-edge slats and double-slotted flaps. The aircraft's frame was mainly aluminum, with some steel and titanium, and the fuselage had a mix of stiffened and honeycomb panels. It also had a fully moving horizontal stabilizer. The bomber used a 3-point landing gear setup, a 2-wheel nose gear, and 2 single-wheel main gears. The main gear door, located in the fuselage center, also acted as a speed brake. Most versions of the F-111 had a terrain-following radar system linked to the autopilot and were powered by 2 powerful Pratt and Whitney TF-30 engines. Its armament included an internal weapons bay for bombs, a removable 20mm cannon, or fuel tanks. It could carry various bombs and missiles, including nuclear options in some versions. The F-111C and F-111F models could carry the paved tack targeting system for laser-guided bombs. The FB-111 could hold air-to-surface nuclear missiles. Externally, the F-111 had 4 underwing pylons for bombs and missiles, with the inner 2 rotating and the outer 2 fixed. It could carry fuel tanks and have stations for electronic countermeasures. Tactical models could mount air-to-air missiles for self-defense, and some versions were equipped to launch anti-ship or standoff missiles. Historically, the F-111 was the first production aircraft with variable geometry wings. a design later used in several other aircraft like the Soviet Su-17 and MiG-23, the US B-1 Lancer, and the European Panavia Tornado. The role that was intended for the F-111B was eventually filled by the F-14 Tomcat. Moving on to a formidable aircraft in the fleet of the United States Air Force, the McDonnell Douglas F-15 Eagle. This airfighter is considered one of the most successful aircraft ever built and is still in service with the U.S. Air Force. Introduced in 1976, it will continue to serve beyond 2025. With nearly 1,200 F-15s built and exported to countries such as Japan, Saudi Arabia, and Israel, it has been produced until 2019. Designed initially as an air superiority aircraft, the F-15E Strike Eagle, an air-to-ground derivative, was later developed. It can load various munitions and has over 100 confirmed aerial combat victories. The F-15 has a robust all-metal fuselage with large, high-mounted wings. The wings have a modified delta shape with a 45-degree sweep and are fitted with ailerons and simple high-lift flaps. It doesn't have leading-edge flaps, but its design, with a low wing loading and fixed camber, ensures good maneuverability. The tail section is made from metal and composite materials, featuring thin vertical stabilizers and horizontal stabilizers that can move independently to control roll. The aircraft includes a spine-mounted air brake, retractable tricycle landing gear, and two powerful Pratt & Whitney TF-30 engines. The cockpit is positioned high in the front of the fuselage, with a large canopy for broad visibility. By the 1980s, advanced titanium parts were added to the design. The F-15 is highly maneuverable thanks to its low wing loading and high thrust-to-weight ratio, allowing it to make tight turns and climb quickly. It can reach 30,000 feet in about a minute and even accelerate vertically at certain speeds. The aircraft's design allows a single pilot to handle air-to-air combat effectively. Single-seat versions are designed for air superiority, while two-seat versions are used for training and combat. It doesn't have the turkey feather exhaust pedals found on some other fighters, as they were removed due to issues during development. In a notable incident, an Israeli F-15D was able to fly and land safely with most of its right wing missing after a collision, proving the aircraft's resilience and leading to further research into damage-adaptive technology. Aside from its mind-blowing agility, the aircraft is also equipped with a range of advanced avionics, including a head-up display, radar systems, and electronic warfare tools. The HUD projects flight information directly into the pilot's view, allowing them to track and target enemies without looking away from the display. The radar systems like the APG-63 and APG-70 can track targets at various altitudes and ranges. The F-15 also has advanced electronic warfare capabilities for detecting threats and countermeasures. The aircraft can carry a variety of air-to-air weapons, including AIM-7 Sparrow, AIM-120 AMRAAM missiles, AIM-9 Sidewinder missiles, and a 20mm AIM-61 Vulcan gun. It can also be equipped with conformal fuel tanks that extend its range but slightly increase drag. These tanks can hold up to 750 gallons of fuel each and can be used alongside other weaponry. The CFTs are used by the F-15EI variant and have been sold to other countries for extended range missions. The Mikoyan MiG-31 Foxhound. With a top speed of 2,153 miles per hour, the MiG-31 Foxhound is a Soviet interceptor designed to take out enemy aircraft. It has a twin engine with a thrust of 2 by 152 kilonewtons and can fly at supersonic speeds at both high and low altitudes. The MiG-31 is equipped with a 23mm gun and various air-to-air missiles, and its production ended in 1994. It remains in service with the Russian and Kazakhstan Air Forces. The MiG-31, like the MiG-25, is a large twin-engine aircraft with air intake ramps on the sides, high-mounted wings, and twin vertical tail fins. Unlike the MiG-25, it has two seats, with the second seat occupied by a weapons systems officer. The MiG-31 was designed to quickly intercept and destroy cruise missiles and their launchers, track low-flying missiles, UAVs and helicopters, escort strategic bombers, and provide air defense in areas not covered by ground defenses. It is limited to a maximum of 5 Gs at supersonic speeds and is not meant for close combat or rapid turns. The MiG-31 structure is stronger than the MiG-25's, allowing for supersonic flight at low altitudes. Its construction includes a nickel-steel alloy to handle high speeds approaching Mach 3. The aircraft is made of 49% nickel steel, 33% light metal alloy, 16% titanium, and 2% composites. It has powerful D-30F6 jet engines, which allow it to reach speeds of Mach 1.23 at low altitudes and Mach 2.83 at high altitudes. Those speeds over Mach 3 can damage the engine and airframe. The MiG-31 was one of the first to use phased array radar, specifically the Zaslon S-800, which has a range of about 200 kilometers against fighter-sized targets and can track up to 10 targets, attacking 4 simultaneously with R-33 missiles. It also includes an infrared search and tracking system. The aircraft features secure data links for communication and data sharing between MiG-31s and with ground control, as well as electronic countermeasures. The flight navigation equipment includes various automatic control systems and long-range navigation systems. The MiG-31 can share radar data with other aircraft and control a large area of airspace. The MiG-31's radar can detect targets up to 200 kilometers away and track 24 targets simultaneously, engaging up to 6 of them. It can also intercept cruise missiles flying at very low altitudes. The MiG-31BM variant has an upgraded radar with greater range and improved performance. The MiG-31M, MiG-31D, and MiG-31BM models have even more advanced radar systems. The aircraft is equipped with a variety of weapons, including R-33 air-to-air missiles, a 23mm cannon, and various types of long-range missiles. It can also carry anti-radiation and anti-ship missiles, precision bombs, and, in some variants, the KH-47M2 Kinzhal missile, which offers long-range strike capabilities with speeds up to Mach 10 and can carry conventional or nuclear warheads. Moving on to the Bell X-2 Starbuster. This aircraft was an American research aircraft that first flew in 1955 and was retired in 1956. It was designed to investigate how aircraft behaved at speeds higher than 1,522 miles per hour. With a back-swept wing to reduce air resistance, it achieved a speed of 2,842 miles per hour in 1956. However, after reaching this speed, the aircraft tumbled out of control, and the pilot was unable to regain control, resulting in a fatal crash. The Bell X-2 was created to study flight at speeds and heights beyond what the Bell X-1 and D-558-2 could handle, and to look into problems with aerodynamic heating, known as the thermal thicket. Its development took a long time because new advances in aerodynamic design, control systems, high-temperature materials, and other technologies were needed. The X-2 went beyond previous manned flight limits in speed, altitude, and temperature, and was the first U.S. aircraft with a throttleable rocket engine and digital flight simulation. The XLR-25 rocket engine by Curtiss Wright was based on an adjustable thrust JATO engine made by Robert Goddard in 1942 for the Navy. One major challenge was providing stability and control at high supersonic speeds, close to Mach 3, where severe heating from aerodynamic friction or the thermal barrier would occur. The Bell X-2, built from stainless steel and a copper-nickel alloy called Cayman-L, and powered by liquid propellant rocket engines with adjustable thrust, was designed to explore the supersonic region. The Mikoyan MiG-25 Fox-Bat. This airfighter is a Soviet jet built to intercept American aircraft during the Cold War, has a top speed of 2,435 miles per hour. Unlike the SR-71, the Fox-Bat is equipped with 4 air-to-air missiles and has participated in many successful combat missions. Over 1,100 Fox-Bats were built between 1964 and 1984, though their use today is limited to Russia, Syria, Algeria, and Turkmenistan. During the Cold War, the Soviet Air Defense Forces, not to be confused with the Soviet Air Force, were responsible for defending the USSR's airspace. This included not only accidental border violations, but also protecting against U.S. reconnaissance aircraft and strategic bombers carrying nuclear bombs. As U.S. aircraft performance improved, the Soviets needed better interceptors. By the late 1950s, high-altitude flights by the Lockheed U-2 showed the need for higher-altitude interceptors. In addition to the subsonic Boeing B-47 and B-52 bombers, the faster Mach 2 Convair B-58 and the Mach 3 North American B-70 were being developed. This required a major upgrade in the Soviet defense system to counter these faster American bombers. In early 1958, a requirement was set for manned interceptors capable of reaching 3,000 kilometers per hour and altitudes up to 27 kilometers. The features and capabilities of the next aircraft would certainly blow your mind. This next aircraft holds the current world record for the fastest manned aircraft with a maximum speed of 4,473 miles per hour. Well, it's not the SR-71 this time. It's the North American X-15. Its design is unlike that of regular airfighters. To remain stable at such speeds, it had a large wedge tail, though this caused significant drag at lower speeds. The X-15 was carried aloft by a B-52 Stratofortress before igniting its engines. It used rocket thrusters for steering, reached altitudes higher than 62 miles, and flew at more than 6 times the speed of sound. The X-15 was based on a study by Walter Dornberger for the National Advisory Committee for Aeronautics to create a hypersonic research aircraft. Proposals for the airframe were requested on December 30, 1954, and for the rocket engine on February 4, 1955. North American Aviation was contracted to build the airframe in November 1955, and Reaction Motors was contracted for the engines in 1956. This aircraft was designed to be carried and launched from under the wing of a B-52. 2 B-52s, called the High and Mighty One and the Challenger, served as carrier planes. It was released at about 8.5 miles high and at a speed of 500 miles per hour. It had a long cylindrical body with heat-resistant nickel alloy parts, retractable landing gear, and skids for landing. The X-15 had different systems and control setups. It operated in various scenarios, including launch from a carrier aircraft, drop, engine start, acceleration, flight into thin air, re-entry, glide, and landing. Its rocket engine operated for a short time, but without it, the aircraft couldn't maintain altitude. For control in low air environments, it had a reaction control system using rocket thrusters. The cockpit had different control setups, one with 3 joysticks and another with 1. It included controls for the rocket engine, ventral tail fin jettison, heated windows, and a headrest for high deceleration. The X-15 had an ejection seat designed for high speeds and altitudes, though it was never used. Pilots wore pressure suits, and the cockpit was pressurized with nitrogen gas. Early flights used 2 XLR-11 rocket engines, providing 16,000 pounds of thrust. By November 1960, the XLR-99 engine was introduced, providing 57,000 pounds of thrust and using ammonia and liquid oxygen. The X-15 also had a reaction control system for maneuvering in low-pressure environments using high-test peroxide. It had a thick wedge tail for stability at hypersonic speeds, producing significant drag at lower speeds. It also had extendable side panels that acted as air brakes to aid stability. Just as you've anticipated, the Lockheed SR-71 did make the list. This magnificent airfighter, also known as the Blackbird, is a retired, long-range, high-altitude Mach 3 Plus spy plane made by Lockheed Corporation. It had nicknames like Blackbird and Habu. It was created as a secret project from the Lockheed A-12 spy plane during the 1960s by Lockheed's Skunk Works division. Clarence Kelly Johnson, an American aerospace engineer, designed many of its unique features. Its shape was based on the A-12 to make it less visible to radar. Originally, a bomber version was requested, but the program shifted to focus on reconnaissance. The SR-71 was bigger and heavier than the A-12, so it could carry more fuel and had a 2-seat cockpit. It was made public in July 1964 and started serving in the U.S. Air Force in January 1966. The Air Force retired it in 1989, mainly for political reasons, though a few were briefly used again in the 1990s before being retired again in 1998. For its spy missions, the SR-71 had sensors, radar, and cameras. It flew very fast and very high at Mach 3.2 and 85,000 feet, allowing it to outrun or avoid threats. If a missile was launched at it, the SR-71 would just speed up to escape. Each plane could fly about once a week because it took a long time to get ready for the next mission. There were 32 SR-71s built. 12 were lost in accidents, but none were lost to enemy action. Since its retirement, satellites and drones have taken over its role. A new drone, the SR-72, is being developed and is expected to fly in 2025. As of 2024, the SR-71 still holds the world record for the fastest manned aircraft, a record that it set in 1976. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.